In this video, I'm going to review some of the basics of the statistical packages that might be available through Python. So I'm going to go through why we do data analysis using Python, and we'll get a brief overview of different packages and why we have so many packages for Python. And then we will go through some of the basics of Numpy, including creating and accessing Numpy arrays and doing some simple matrix operations. Alright, so why do we need all these packages such as Numpy and Pandas and other statistical packages? So I have emphasized throughout this course that Python is a general purpose language and it's very friendly for programming and also very flexible. Accordingly, there's been a lot of developers that put together different packages, including Numpy and Pandas, in order to help us tailor some of the benefits of Python for data analysis. For instance, we have lists in Python. I mentioned that lists are gonna take a long time to process in Python, given that we can put different types of data in lists, and lists can be modified in different ways, they're mutable. In the same way, analyzing lists is going to take a long time. So because of that, there have been efforts in order to develop different types of data structures, including arrays in Numpy and data frames in Pandas. And the point of these is to facilitate a statistical analysis in a way that it's a lot faster rather than using traditional, let's say, lists or tuple in Python. What are some of these packages? We have Numpy, that's very useful in terms of working with matrices. We're going to go through some of the basics of Numpy in this video. We also have SciPy, which is a package that's directed for machine learning. It's very great for handling that kind of data. You might have heard of Pandas, which is also very efficient in terms of handling large packages of data. So if you've heard of like data analytics, and if people who are interested in handling large data sets and running a statistical analysis with that, Pandas is very powerful. We'll go through some of the basics of it. We also have another package called Matplotlib. Matplotlib is great for visualization if you would like to see some trends in the data. And there are other packages, Seaborn and other. And also if you have used R or even SPSS, these packages can work with Python and offer more features. In this course, we're going to go through these three at least, and if we have more time, we're going to tap on some of the more advanced packages. But first, let's start with Numpy and go over some of the basics of Numpy. So first thing first, in order to import Numpy into Python, we usually import packages by writing a function called import. And also, if you want to use a shorthand name, which is optional in order to use it later on when we want to use functions and methods related to Numpy, we can assign a shorthand name. I'm just going to call it as NP. But this was again optional. We could just use the whole name as we go through the analysis. So let's start by creating a simple list. I'm going to give it 3 numbers. And now the first thing I'm going to do, I'm going to create arrays. I'm going to call this array ARR, and I'm going to say NP, again shorthand for Numpy, and array list. So this basically will turn the list that we have created into an array that can be worked through using Numpy packages. Now let's print. We had our list, we have our array, and we can separate these. Alright, so let's see what we have. So now we have a list, and now we see that our array is very similar to the list with some differences. Basically, there's no more commas, and we're starting to form our data set into more like a structure or more like a matrix. Now if I want to print the type of the array, we will see that we're getting class, it's Numpy, and the type is ND array. So let me talk a little bit about ND array. So I'm going to paste some information here. So ND array is standing for the n-dimensional array. It's a multi-dimensional container of items that can be understood by Numpy packages of items of the same type and size. Typically, we're talking about a set of non-negative integers, and the size of the array basically specifies the dimensions related to number of rows and columns. So let's go through some examples just to see what we mean. So we have already created an array, right? So we have an array that is a set of numbers. Now next thing I want to do is let's try to create another set of arrays. So I'm just going to say let's have another list that includes numbers 4, 5, and 6, and we want to create array 1 now in the same way that we created that. So now let's print ARR1. So we have that one turned into an array. Now I want to do a little bit more sophisticated way of creating lists. We could have said let's create an array now. So we say np.array from the values that we have now created in list 1, or we could have just used ARR, but I'm just going to go back to lists and list and list 1. Okay. I'm going to say print. So we see that now we have starting to see a different structure. So we have the numbers that were traditionally in a list, but now it's starting to form a matrix. Now, a couple of the other functions we can run once we turn something into some sort of a matrix. So we can check the shape. We said ND arrays have a specific shape, so we can call that by using this. So we see that it's 2 by 3. So basically we have 2 rows and 3 columns. That's the shape of the matrix. We can also run another function. I'm just going to call this mx. We can check the data type. That's including that. So we see that it's integer 64. So basically we have numbers in that. In the same way that we can now run functions or methods to call different values in the list, we can use similar methods in order to work with ND arrays as well. Let's say if I'm calling mx0, I'm going to have the first row if I was now calling, let's say mx0 and then value 1, we should be able to see the value that's in the first row and in the second column. So we should be able to get 2 out of this. And again, if we're like just simply printing mx, we will see that value is going to come out. We can also change some of the values in here. Let's say I can say assign a string. Let's say I want to give a value string to this function, a string to this matrix. Now let's print mx again. So we see that now we have a value that's in it. But what if I change that into a piece of a string? We see that when I did 20, Numpy automatically changed that into a value that's an integer. But if I'm actually giving a string here, then we will get an error that it will not accept that value. So basically, the type of values that we can put in these matrices are generally positive integers. I can just leave that as a comment here. So Numpy arrays work with elements of the same numeric data type.